Hello, I'm that tech guy. Now we're creating a smart contract to deploy a Mac management system. Let's say student Mac management system. Now, at first, what this a smart contract virtually is that in this contract the details of student, like the student ID, the names, the marks, several etc. information will be added, and if you want to also give bonus mark, like I said, because we are using Mac management system, you can also give bonus mark to a particular student. It will add to that existing mark. So probably what we'll be deploying our contract using Remix IDE. And so when you put your Mix ID, the first thing to do, of course, it depends on your workspace you're staying on. You can work on any workspaces available. So I will just create a new file, and I will name it Mac. You can actually give it any name though, so it's not really necessary you give it that one. Mac management. I'm just trying to make it so meaningful. Now I've been able to create that file, so let's close this. Yeah, this is a Mac management system, the extension.seo. So the first thing to do is to get your license and also get your versions. Now there's a shortcut, so you can simply just type in pragma, and simply it brings out that prompt. Press on tab, so automatically it gives you that content of you specify your license. Automatically specify your license, which is by default MIT, and you have to input your Solidity version. So let's just use greater than 0.8 sorry, 0.8.16. Yeah, so I'm going to be giving comments so that we have understanding of what we are doing. Smart contracts. And manage them to add student, and get student. Alright, so this I'm just giving a comment section so that we understand what we're doing. So I'll create a contract. Now I can just say student Mac management system. You can actually give it any name you want, but I'm just trying to make it understandable. So the first thing to do, what I'll be needing actually, I'll be needing struct. I've been able to list out the variables or the data types I'll be using. I will need struct. I'll need an address. I'll also need a mapping. I will need modifiers. Then I will need constructor, and then function. This is what I've been able to structure out that information I've been able to create this smart contract. So the first thing, like I said, I will need struct. So I will have to create a struct of students. Now, what this actually did, houses other information of containing regarding to students. You can create a struct, and a scenario is a struct of a school. A school can have, of course, underneath that school have the school name, school location, school details. But for this tutorial, we'll just be needing for information. I'll be creating a struct student, and what I'll be needing, I'll need the ID. Then now, when you're creating a struct, you have to terminate with the semicolon when you specify the data types and the variable name. And I will need the string first name. I will need the string also. I will need the last. These are just basic information, but because we're trying to create a Mac management system, so which is why I'm just trying to shorten, giving these 4 values. So these are what I'll be needing underneath struct. Struct is like the house, I would say struct of student acts as a header which contains the features of ID, the name, the last name, and the marks. So this is just the struct to house features of students. That struct allows you to create a other data types or other features of a particular data, such as students. That struct gives you that it gives you that ability to do that information. So after the struct, what I'll be also needing is the data, no, sorry, the address, yes, which the address which I've been able to do here, which I'll actually do now. So I'll create an address owner. I'll be needing, this is not really relevant now, but I'll be needing it because this owner indicates that the person calling the smart contract. Where this is applicable, when moving forward, I'll make reference to it. Well, I will just create an address owner so that this houses the address of the smart contract, but it has not been initialized yet. So let me address to be assigned smart contract owner. I'm creating this comment so that you can have an understanding of what I'm trying to do, so that you understand, giving more details. The one I'm also doing now, if you are creating this student mark management system, of course you have to know the number of students that is available. So I will be counting the number of students, or I want to know the number of students that's available, which is why I'll be giving an int public std. This is just a variable name, to shorten it. You can use anyone. I will initialize it to 0. So it means I have to make data type of int, sorry. Then the visibility of public means, okay, this number of student count, it has to be made public for the user to interact with. The user has to know, okay, this is number of students. So this is why I'm giving that public visibility. Students count. Now create a mapping. Sorry. Now I'll create a mapping. It's also a data type in Solidity. Now this mapping is housing two different values. You can house two different data types. I'm housing an int value. Then this int value is referencing the struct student. It means any int value I'll be putting, any numbers I'll be putting, should reference this struct student. It means when I input 1 or 2, depending on the kind of value, should reference the struct student, so that anyone that is assigned to 2 or 1 will bring out this information of the ID of the student, the first name, the last name, and the marks of the student. So this is simply what I am doing. Okay, student. Now I will make this mapping public. Now I will assign it a variable name of student records. This is mapping to input in value and return student record. So what I'll also creating next is modifier. Like I said, this is a mapping. Any int value I'm putting, we reference the struct student and give out that particular information. Now this mapping is public, and I'm assigning a variable name of student records. Student records is acting as a mapping, so that when I input an int value, to give out that particular record pertaining to that value. So I'll create a modifier. Now I'm creating a modifier which is called only owner. Now this modifier is, what I'll be doing with this modifier is to ascertain that, okay, the person that is calling this smart contract should be the one that owns that smart contract. If it's not the one owning that smart contract, there's going to pump out an error. Yes, so what I will illustrate with this is that in this modifier, it gives information about that smart contract owner, the person that is calling this smart contract. It gives that information about the person. If it is not the person that is calling that smart contract, it will give out an error that, okay, this is not the owner, depending on the prompt I'll be writing. So in essence, I would just say it's a special function that will modify other functions, or it will modify the behavior of other functions. That is the calculation I'll put in modifiers. This modifier in Solidity is a special function that actually modify the behavior of other function. Now the essence of this modifier is that it allows other developers actually to add a condition to a particular function. So that is the essence of this modifier. I'm adding a condition to this smart contract or to a particular function, such that I will make sure that this person that is calling the smart contract should be the owner of that smart contract. Else it should bring out a prompt that he or she is not the owner of that smart contract. So this is why I'm using this introducing modifier. So I'm using a modifier, then I'm naming it a variable. Of course, I'm naming the variable only owner. Then because I'm using modifier, like I said, it allows me to specify conditions to other functions. I will use the require. Now require is also a function in Solidity. It is used to verify input and condition before it executes. This require will specify the input and condition before it executes, such that if this condition is false, of course, then require that information should not go. If it is true, okay, require that it pumps out another information. This is why I'm using require in this smart contract. So I have to require that this information that I'm using, or that I'll be putting in, should be equals to that person that is calling that smart contract. So which is why, let me now put it in codes. So I should require that this owner, which is the address here, should be equals to message.sender. Now message.sender shows, it calls the address of this particular contract. So this message.sender means calls this address they are calling, save it in this variable name owner. And remember, in this variable name owner, I have assigned it as the same data type. It must be of the same data type, which is address. This variable owner has a data type of address, and this message.sender also houses an address. So this address of message.sender, it saves in the owner. So now require that the owner is equal to message.sender. Otherwise, it should prompt out the message that you are not the owner of the, like I say, you are not the owner of the contract. Then I have to terminate. I have to terminate this one. When you're creating a modifier, and when you're terminating it, you have to remember to terminate with an underscore, then semicolon. That is what you use in terminating your smart contract. You have to use a semicolon to terminate the smart contract. So the next thing is for me to I'll create a constructor. Now the essence of me creating this constructor is in such a way that at the initialization of this smart contract, it will initialize that address, assign that address to it. So let me just simply create it here. Now constructor in Solidity is a special function that is declared. Of course, you use the constructor keyword, this keyword there, it is declared. Now it is used to initialize the state variable of a contract. It means at the beginning of that contract you initialize it. So it is declared, of course, like I said, it's declared using the constructor keyword. It's a special method, actually. Like I said, it's also a special method, and it's also a special function too. It gets called whenever a class is initialized. It gets called whenever this smart contract is initialized. That's the essence of this constructor that I'm introducing here. So I'm saying, okay, constructor, of course, then open your curly braces, owner is equals to message constructor. Okay, yes. In using this constructor, I have to make an initialization of this smart contract, that the owner, which is what I specified here, which is an address, should be equals to this smart contract being called. That's what I'm saying, that this constructor, when it initializes, when it starts, it should, at the initialization of the program, it should make sure that this owner, which is this variable name owner, which is assigned an address, should be equals to the address that will be assigned to this smart contract. So that is the essence of me introducing this constructor. Initialize the smart contract. I have to initialize the smart contracts. Okay. Now, like I said, okay. Now look at this information. It's just showing an information of gas. That one is what you can actually ignore for now. It's showing 227 3110 gas, then 197 800 gas. It's something that you can actually ignore for now. So going further, I've been able to create my modifier, I've been able to create an adjust, and I'm able to create the constructor. So what I have to do next is to create a function that will add new record. It means, okay, you're trying to input this record, so that function of course must be public, it must be what the user can see, so that when you just click on this function, it's going to add a new record to it. So I'll be creating that. Okay, let me for this, for learning purposes, I'll be using comments to explain this. I'm going to ascertain the owner of contracts. Then function, okay. So add records. So I'll go to function using the function keywords. Adding new. Now, adding this record, I'll be needing 4 details. Now, referencing back to my short of students, what I've created here. If you look at this information, it means, okay, I'm requesting for an ID. In this student, there's an ID, there's the first name, there's the last name, then there is the marks also. So eventually, what I'll be needing is, in this new record, I will need the ID, I will need the name, first name, I will need the last name, then I will need the mark that I'm inputting. So I will add new record. By adding new record, I will use int underscore ID string memory underscore first name, then string memory underscore last name, sorry, comma, then int max. I'm sorry, please. I don't know why it's acting slow. Okay. Sorry. I have to make it public. Now, if you should observe in my function, in the acceptation of value that I'm requesting for here, in this function, I'm saying, okay, request for ID, first name, last name, and the marks. Now, we should observe it an underscore. Now, in Solidity, it's advisable to use underscore when you are specifying the input, the acceptance of value in creating your functions. It's advisable so that for better structure of your codes and for understandable of your code structure, so that for differentiation also is advisable to specify your when you're accepting value in your function with an underscore. So which is why I'm putting an underscore here. Now the variable name I'm using here doesn't necessarily have to be according to this. I'm just using it for better structure purpose. You can assign it to any variable name that you wish. Now we should observe when I'm specifying my function and then some data types and the variable name, I'm using memory here, string memory. Now this memory is a keyword that will actually store data temporarily during execution of the smart contract. Because I'm using this memory keyword, it will store that information. Of course, it's string. It will store that information I'm using temporarily when it executes the smart contract. Now, when this variable name is declared, or this first name, last name, and the first name and last name is declared using this memory keyword. Now, it is stored in the memory area of the Ethereum virtual machine. Now, this is a default location for variables, or of course for any variables in Solidity, but because I'm using string, I have to specify that okay, this string that I'm using, it should store it temporarily during this execution of the program. Now the variable name that I assigned is underscore first name, because it's declared using memory, it has to store in the memory area of the Ethereum virtual machine. So that is the excess of me using this memory. It has to be stored there. Now I've assigned the public, then only owner, sorry. Why I'm using this only owner, like I said, is declared here, which is a modifier. It means okay, from this function, go back and inherit the features of this modifier, which is called the variable name, which variable name is called only owner. It means the features, which is what I use here, require inherit the features of this modifier require, which is owner equals to body sender message dot sender, then you are not the owner of this contract. In this function, when it's execution of this function, it should go back to inherit these features. So it runs with this features modifier at the same time when this function is being called. That's the excess of me assigning, giving that only owner. Then now, using that, I have to increase my student count when I'm adding new records. At the same time I'm adding new records, it has to count. Okay, I'm adding new records, I have to count by 1, count by 2, count by, depending on the number of student records I'll be inputting. So increasing the count by 1. So I'll use the std count, which is the variable name that I've done, which is std count, and I've assigned it public. So which is what I'm doing here. I have to count because I've initialized it to 0, so I have to also initialize it again. So for now, just we'll ignore this. This is unused function parameter. We'll still use the function, so ignore the error code there. So it means when I'm calling the new function add new records, it has to increase the number of counts by 1. And what I'm to do, you have to fetch the student details. Sorry, I have to fetch the student details. Now, fetching the student details will involve me using the student count. So if I'm fetching the student details, I have to use my mapping student records, and std count is equals to students, then underscore. Now, okay, before that, so this is a map. If you remember, I've structured it here, I've laid it down here. It's mapping to input int value and return that student record based on that int value. So at the specification of the mapping student records, it has to accept an integer value here, which is why I'm placing it. Accept the first value is accepting the integer value. So as student count, if you remember, here is also an integer value. So at the input of student count, which is adding to 1, now it goes back to the struct student. It goes back to this struct student at the input of 1. It inputs that the values here. It inputed it. Okay, I'll input the ID, I'll put the first name, input the last name, then input the max, which is why I'm using this student record. At the count of 1, go to the student record and give me the details. Go to the struct student and give me the details of the ID, give me the name of first name, give me the last name, give me the max, which is what I'm referencing here. So I'm saying, okay, at the mapping of student records, and at the input of 1, when it counts to 1, input that value, which is the int. Then it goes back to the struct student, which I will place my ID. Get me the ID, get me the first name, get me the last name, and also get me the max, not mac. Now this is the essence of this function, which I've done here. Now going forward, I have to also create a function that would add mac. So let's say, okay, our function bonus mac. Now this bonus, of course, it has to be int. When you're adding mac, you have to add an integer number. Then I'll make it public. Now also probably I have to make it inherit the modifier, which is the only owner. So for learning purposes, I'll be using comments also. Function to add bonus max. Now in this function, what I'll be doing is to add the student record. I'll add a student record to the value of max. Now let me explain that in code. Now, because I'm adding max, so it means you have to go to student records. Then from this student record, at the count of mapping, like I said, because I'm using a mapping, so student record is the mapping variable name. Then at the count of 1, go to that structure of student, when it goes to the struct of student, get me the marks. It means dot marks. Now when you are calling a struct, or you are referring back to your struct value, you use the dot value to reference your struct. So it go back to the marks, to the struct student of marks, then it add it to the bonus value. This is the variable name bonus. Add it to the int that we assign to this bonus value. So this is what I'm simply just telling the smart contract. Now we're able to come up with this. Then let's see, when we deploy, let's see how the function is. If there's any addition that we need to do, then we'll make amendment to it. So I will save, which is Ctrl S. Now when I save, remember, you look at this. It's compile. Make sure that your compilation is successful. Then go to your compilation is successful. Then go to your deploy and run transaction. Now this is where you'll be deploying your transaction. When I click on deploy, so of course you go down for a while. Now when I deploy, make sure you are looking at your terminal. It shows that okay, it has been checked. Now your contract has gone through. Now we'll look at all this step by step again. So from here on, now look at this. Look at these colors. The colors are quite different. This is a function, and this is not a function. This is just a data type of which I've assigned it to be public. So because I'm assigning it public, that's why it is visible here to the user. So when I click on the student record, it's going to show me 0. Like I said, at the initialization of this smart contract, it is 0. So now going back to the main function of this smart contract, I have to add new records. No, I have not added any records already, so I have to add new records. This new record, when you click on this tiny button here, it's going to show you the requirement, what I'm asking it to input. So from this function, add new record, it shows that okay, get the int id. I should input a string, input another string, last name, input another string, max. So from here, id, let's say okay, let's give it an id of 1. Then first name, let's say that tech guy. Then last name tech. Then mark, let me see, I'll give it a mark of 50. Now when I've input all the values, just click on transact. Now when you're clicking on or using the deploy and run transaction, also at the same time be looking at your terminal. There are some operation that's going on in terminal. So you see that it is checked, it means that's successfully gone through. Now open your terminal by clicking on this arrow. Then you scroll down, looking at the details here. The main details we're actually after is our decoded input and our decoded output. This is what we're after here. So our decoded input shows that okay, our ID, I've assigned it to 1. The first name, the tech guy, the last name tech, then the max is 50. Now the decoded output, for now it is nothing here, but this is also that okay, these are the values that I've been able to input, and of course you can now close it. So because I've added new value, and in my function I said that when I'm using that function of add new value, it has to show that the student has to count. So it means it's counting, is adding 1 because I've been able to add new record. So it will add 1 to that existing std count variable, which shows that it's 0. So adding 1 to it will give us 0 plus 1 will definitely give us 1. So when I click on the function std count, it shows 1 underneath it here. So that okay, I've added new values of 1. So let me add another new record. Then let me see. Go back. Now there are two ways of inputting these two records. Now if you know that this is what your function is doing, so you can just come here directly and input it. It's 2. Then comparing your function acceptance of value of your function. Then okay, names. So this is at random. Then the last name Tom. Then the max 80. So I click on add new records. Now checking your terminal here also again to ascertain the record that we inputted. You scroll down to your decoded input, shows that the ID is 2, the first name is Lio, the last name is Tom, and the max is 80. So I also check my student count function again. It counts to 2. So that is the excess of me adding this student count. So I saying that when I add new record, it shows that okay, of course the number of records I've added is now 2. Now for us to retrieve the information if you look at this place where I added to STD records, this is it here. I'm creating a mapping of STD and making it public, accessible to the user. So that when I input an int value, an int value can be 1, of course, we know what an int value 1, 2, and 3, etc. Now, but because of these records I've added only 2 records, which is 1 and 2. So when I input 1 or 2 as the int value, now if you look at this information, is showing 8256, means is requesting one int value. So when I input int value, which is 1, and from the function that I've said there, I said that okay, at this mapping, creating a mapping, when I input 1, you should go back to the struct of students and get me the details of that assignment, of that information that is assigned to 1. So which is why also in this add new records, also I did that mapping here. It says at the student records here, at the count of 1 or 2, depending on the number of records that I've added, go back to the struct student and get me the ID, get me the first name, get me the last name, and get me the mark that I've inputted. If you remember that I inputted the records from here, I specified that okay, ask for the ID, ask for the first name, ask for the last name, ask for the marks also. Now let's say because I'm adding new record, and from the initial stage I've created the mapping to show that okay, when I input any of this value, you should go back to the struct and I'm signing the public. Now in this new record, and as I specified that when it has added new records, also in that same function of adding new record, make sure that the mapping that I've created here, when it's assigned any value of 1 or 2, you should save it in this student. You should save in the details of the student that I've given here. The details that I've given here, you should save it in that struct of student. So which is why when I'm using this STD records here, it shows that okay, when I input 1, go back to that the struct of information of the student and get the details that is assigned to 1. So when I input 1 and I click on the STD, click on the function STD records, so it shows that information that is already assigned to it. You see, this is ID 1, the first name, that tech guy, the last name is tech, the max 15. Also go back again, then I input 2. Now it gives me that information again. You see, this is what I'm talking about. It gives you that ID 2, the first name Lyle, the last name Tom, and the max is 80. So this is the essence of what the smart contract is. Now also going further, to explain this modifier, remember like I said, this constructor is at the initialization of the program. Now if you should scroll up in your deployment transaction, if you look at this account, then look at the address that is calling this smart contract. This is it here. Now let me copy it and paste it somewhere so that you have an overview. Now this is the address that is calling the smart contract. Now because here I'm trying to illustrate the essence of this modifier and the require function. Now because they have initialized at the constructor and initialization of this program, assign that the owner, which is an address, you should save the address into this owner, the person calling the smart contract. You should assign that the person calling the smart contract is message.sender. That address you save into this variable name address. Now when I change this account to another person, then say I change it into this OX ABC, then I try to deploy and try to run any functions here. Let's say okay, I try to run any function here of, let me see, okay, of the function. Now I'm going to look for the function that has that features of only owner. Okay, this function add new records. Now let me add new record using another address. So I go to, okay, let me see, number 3, comma, then the first name again, I'll use Yum, then the last name Tan, then add a max 90. When I click on add new records, now go back to your terminal and observe the information that is given there. In this terminal, you see that it's revert. It says in revert in this terminal, it says the transaction has been reverted to the initial state. Reason provided by the contract: you are not the owner of the contract. Debug the transaction to get more information. Now this simply says that the person calling this smart contract is not the owner of this smart contract, which is the information I specified here. I said that okay, modifier only owner, it should require that the owner must be equals to the person that is calling the owner, which is the variable name assigned as address, should be the person that owns this smart contract. which is the message or sender houses that address of the smart contract, it should be assigned to the owner. So you require that that owner should be the person calling the smart contract. If not, it should shows out that you are not the owner of the smart contract. This is the initial address that calls the smart contract. Now, because I changed that account to another address and I called the function to add new contract, it will give me that error message that I am not the owner of the smart contract. Hence, it cannot initialize that program or this smart contract code. This is the the function of the smart contract, and this is what the joy of a smart contract. So now, if I'm changing it back to the original smart contract that's called this, and I try to click on add new records, so if you observe in my terminal, it shows that green check. It means I am already the owner of this smart contract. That's why it was able to go through. If I'm not the owner, it would not go through. So let me go back and check my student count. It shows that okay, I've added 3. The total number of information or students added now is 3. So I want to get that information. I'll go back to my STD records, then I click on. Now it gives me that okay, the ID is 3, the first name is Yom, the I name is Stan, and the max is 50. So that is the essence of this constructor and the modifier. Now we have not used the function of bonus mark. So what we'll do here, let's try and use the function of bonus mark and see if there's any modification to it. Now, using this function of bonus mark, I say okay, function of bonus mark, I make it public. Inherit the features of the only owner. It means I have to make sure that I'm the person that holds this contract, that is calling this contract. Now it's going to do in such a way that okay, I say STD records, which is of course the mapping. Then at the count, maybe 1 or 2, go back to the sort of students, then dot. I'm accessing that particular data type of max, or the particular variable name of max. Now I'm accessing it, which I'm calling by dot. So add it to the initial value I'll be giving, which is the initial value of int. If it's 2 or 3, I'll be giving. Now add that max that is existing to the new integer value that I'll be giving. So which is what okay, let's try it here. If there's any modification, we would see to that. So if I'm learning okay 2, okay, now remember this is 3. Okay, let's say this is 3 here, the max is 90. So bonus mark, let me add 20 as the okay, let's say it's over 100. Let me just add 5 as the bonus mark. When I click on bonus mark and you look at your terminal, see that it has gone through. Now check for us to be ascertained. Let's check okay at the STD records of 3. Now if you look at your information here, observe that it has changed there. It shows that okay, the new mark for Yom for ID 3 is now 95. Now let's check, but I'm looking at it here, I think something is missing, because if I'm saying that you should call that particular STD count at the count of 3, you should only call the number at the count of 3, and that the last person should be the one to have that bonus. I think this is not right. It should be done in such a way that I can add it to any particular ID or any particular person. Maybe I can add it to ID 1, I can add a bonus mark to ID 2. But I think this function, looking at it now, what the function is doing is only adding it to ID 3. So let's see. Okay, let's go back here. Let's say I add 2 again and I check. Okay, let's check this STD records of 2. Now 2 is 80. Let's say I want to add 2, let's say 2 marks to 80. Then I click on bonus mark. Then let me click on this STD records again. So if you look at it, it's not changing. So it means there's something wrong with our function. We have to modify our function. Check the function's text or code. Now let me go back to 3 again and click on it. And let me see 2 here is not changing, it's not adding anything here. So let me check my records of 3. Now if you look at it now, it is 100. So that means there's something wrong with our function. Now what our function of bonus mark, it means our code we've written here means that at the mapping of student records, the student count, remember it is 3, the total is 3. So it means it's only assigning that student number of 3 as the student record. It's only assigning mark to this student count of 3. So it means at the student count of 3, go to the short student and get the mark of that, the third ID, the number 3 ID, and get the mark and add that bonus mark to it, which is not what we would like our function to be doing, because we can't just be adding 1 mark to a person. So what we simply do is, let me comment this out. Let me copy and paste it, and Let me comment this out. So for us to understand this, now what I would prefer we do is that this function must be able to handle this smart contract in such a way that it should only add to it can be added to other IDs, maybe ID 1, maybe ID 2, ID 3, ID 4, depending on specific number of ID. So what I'll do is, instead of me assigning it student count, I should assign it the number of IDs. Let me see. Okay, now if I'm assigning the number of ID, look here, it's going to bring out an error. Now it says undeclared identifier. Now where is this coming from? So this error is coming from undeclared. The acceptance of value of bonus mark, I didn't input it here. So what I have to do is, now this is what I have to do here. It means I have to accept a particular ID, then I have to also accept the mark that will be assigned to the ID. So this is what the excess of the real function of bonus mark is what supposed to be doing. So it means at the specification of a student records, then the ID will be given, maybe ID 2, maybe ID 1. Now go to the mark of that particular ID from the struct student here. Go to the mark here, which is, of course, how to get the mark using dot value. Then when you go to that, get that mark that is existing on that particular ID, maybe ID 1 or 2, then add the bonus that will be specifying here. So this is the essence of this function. What I would, because I've modified it, I have to resave again, then I have to deploy my transaction again. Sorry, let me just delete this. I have to deploy again. Okay, now I have to add new records, of course. So because I've terminated the previous one, so let me say 1 the tech guy tech 90. Okay, now in my terminal I should check. So let me to 2 Tom Tayu, then let me say 80. Okay, let me add the third record 3. Inca, then Yan, this is 70. Now I've been able to add 3 records. So student count, we should definitely give me 3 records. So now let me get the information of 1. Now look at it. Now that information is right. Information of student records of 2. Now look at it. That is Storm. Then that is Storm. Okay, then information student records of 3. We give me an ID of 3. We give me the first name as the Inca, then the last name as the Yan, then the max definitely is going to give me 70. So these are the information that I just inputted, actually, compared to the previous one that I had to terminate this one because of the new function of bonus mark, because of the modification we made. So that is why I'm redeploying our transaction. Now what we have to do is now we should test our bonus mark. That is what I'll be doing now. So let's see now. In my student records of course of ID 3 Inca, his mark is 70. So let's try and add 10 to it. So his mark, like, give me a bonus mark of 10. So I'll go further to add. It says the input is asking for an ID. I should put an ID as also input. I should also input bonus mark I want to add. So I the ID of 3, then separate by comma, let me add 5 marks to it. Then I click on bonus marks. Look at your terminal from here. You see that it has gone through. So now check to confirm. Also, you have to check, of course, your student record and ID of 3 to check to confirm. Now look at it. The new information that's added now. It shows that 75. That's the bonus point I've added. So let's see. Let's check the information of 2 ID 2. Now I want to add 5 marks. Let's give Tom 5 marks also. So from the bonus mark function, ID will be 2, Then I will input the max, which is comma 5. Then click on the function. It shows that it has gone through. So to confirm again, also check from the student records. It shows that of course I've successfully added 85. So this is the essence of our function. Student record of 1. Let's see, ID 1, that third guy. Let's add 10 marks to that third guy. So I have to know the ID, of course, because the ID is 1. Then comma, I have to put, let's see, 10 as the bonus. Now when I input 10, let's now confirm the records. It shows that this is 100. So we have been able to understand, the essence of this smart contract, what it does, and it's of course network management system. This is a simple smart contract to display the function on the program to check for add student and also add marks. So thank you for listening. I'm Datega once again. Kindly like and subscribe to my YouTube channel and check other videos for more understanding and works other smart contracts to do. Thank you very much.